In this video, we are going to implement the Dijkstra algorithm in Python to find optimal path. A couple of weeks ago, I came across a science paper, Application of Graph Theory to find optimal paths for the transportation problem. The connected graph is quite interesting. The paper is available on the Elsevier website, sciencedirect.com, and is free to access. Before I continue, I'd like to give credit to the University of Pristina, Faculty of Mechanical Engineering, and the University of Technology Vienna and Science Direct for granting access to this paper. The website link to this science paper is available in the description below. This paper describes the application of graph theory for finding the optimal paths with a focus on the transportation and finding the minimum shipment cost. For finding the optimal paths, two algorithms are applied: Kruskal algorithm to find the minimal spanning tree, and the Dijkstra algorithm to find the shortest path between the two vertices. The given connected graph is a bit overwhelming at first, but it comes with the challenge to find the shortest path to reach from vertex A to vertex B. Let me show the connected graph. The connected graph consists of vertices and edges. The vertices are also called nodes. The blue circles in the diagram. The connected lines between the vertices are edges with associated weights. In this video, I would like to focus on the Dijkstra algorithm. In the next video, I'd like to show the Kruskal algorithm using the same connected graph. For more detailed information on the Dijkstra algorithm, please read the Wikipedia page. The Wikipedia page also offers two different pseudocodes. I chose the first pseudocode to follow, thus without a priority queue. I will follow this pseudocode as much as possible. You'll find the link of the Wikipedia page also in the description below. Okay, enough said. Let's start coding. The first step is to convert the connected graph into data structure. You can choose either data structure on the adjacency list or the adjacency matrix. I chose the adjacency list. First line of code is the adjacency list. Each line in the adjacency list consists of a particular vertex and set of neighbors with the associated weight of the edges. Two vertices have an uppercase letter, A and B. All other have a lowercase letter. Both letters A and B stand out since the challenge is to find an optimal path between these two vertices. We define a variable called start as the starting vertex to find the optimal path. In the following three Python statements, we are defining storage for all the unvisited, neighbors, and weights. These will be used while searching for the optimal path. Next, we are going to initialize these to keep track which vertices needs to be visited and their associated neighbors. We are going to set the neighbors to the value none, the weights to infinite, and all the vertices are unvisited. Weight of the starting vertex A to 0. The main loop, while unvisited, will repeat till all vertices have been processed. If one vertex is visited, the vertex will be removed. In the main loop, there are two for-in loops. The first for-in loop searches for the lowest weights by comparing. The second for-in loop finds the shortest path between the vertices. We set the ending vertex to B. Based on the list neighbors, we are going to find the shortest path between the vertex A and B. We are showing here all the vertices between A and B by compiling the shortest path with the least weight. The final result is AIH GOB. The same path is described in the science paper in Figure 28. Now, let's go back to the connected graph and verify the result, and if needed, this is the shortest path with the least weight. In this connected graph, the shortest path with the lowest weight is shown in orange. I would like to thank you for watching the video. I hope you have a better understanding of finding the shortest path with the minimum cost using the Dijkstra algorithm. Do you still have a question? Please leave a comment below. If you would like more videos about Python, please subscribe to our channel and hit the bell icon.